Welcome to clickmyproject.com. We discuss about the project content-based lecture video retrieval using speech and video text information. Let me discuss about the abstract of the project. The video will be retrieved using content-based video search for the input of speech and video text content. There are many lecture video data available online, so need to detect text from that lecture video. There are many methods are available for text retrieval from video. Here a more efficient method has been proposed. In this first step, video will be converted to frame. During frame conversion, videos are separated into image format. Then pre-process each frame. In this step, noise has been removed from each frame. After that, the Canny edge detector has been applied to predict the edge. This process is repeated until all frames edges will be detected. Next feature has been extracted from each frame. In this process, use HOG feature extraction method for extracting the feature. Finally, SVM classifier is used to classify the text frame from the all detected frames. The Canny edge detector is an edge detection operator that uses a multi-stage algorithm to detect a wide range of edges in images. This edge detector method detects the edge in our frames. Histogram of oriented gradients or feature descriptors, which counts occurrences of gradient orientation in localized portions of an image. With HOG feature extraction method, extracts gradient values of all frames. Finally, SVM classifier is used for classification. Support vector machines are supervised learning models with associated learning algorithms. Given a set of training examples, each marked as belonging to one of two categories. SVM training algorithm builds a model that assigns new examples into one category or the other, making it a non-probabilistic binary linear classifier. The HOG feature extraction method extracts the gradient values of all frames. Finally, SVM classifier is used for classification. Let me discuss about the flow diagram for our process. First, capture the lecture video from database. Next, in the frame conversion, convert the videos into frames. The size of the film frame varies depending on the still film format or the motion picture film format. A film frame or video frame is one of the many still images which compose the complete moving picture. The video will be read and we convert the video as frames. The converted frame will be saved. Next, in the noise removal, that is pre-processing step, user can able to change the size of the image by providing pixel height and width with the help of impresses function. Select blur image with a specified blur type by choosing the filter type with the help of a special and mFilter function. This Gaussian filter is windowed filter of linear class. By its nature is weighted mean. Motion filter is apparent streaking of rapidly moving object. Next, in the edge detection process, here Canny edge detector is used. The Canny edge detector is an edge detection operator that uses a multi-stage algorithm to detect wide range of edges in images. Canny's aim was to discover the optimal edge detection algorithm in a multi-scale operator algorithm to detect a wide range of edges in images. Is a good detection. The algorithm should mark as many real edges in the image as possible. Good localization edges marked should be as close as possible to the edge in the real image. Minimal response, a given edge in the image should only be marked once, and where possible image noise should not create false edges. To satisfy these requirements, Canny used a calculus of variations, a technique which finds the function which optimizes a given functional. The optimal function in Canny edge detector is described by the sum of 4 exponential terms, but it can be approximated by the first derivative of the Gaussian. Canny edge detection in a 4-step process. Gaussian blur is applied to clear any speckles or the free of the image of the noise. A gradient operator is applied for obtaining the gradient's intensity and direction. Non-maximum suppression determines if the pixel is a better candidate for an edge than its neighbors. Next, in the feature extraction process, here HOG feature extraction method are used. Histogram of oriented gradient is feature descriptors used in computer vision and image processing for the purpose of object detection. The technique counts occurrences of gradient orientation in localized portions of an image. This method is similar to that of edge orientation histograms, scale invariant feature transform descriptors, and shape context, but differs in that it is computed on a dense grid of uniformly spaced cells and uses overlapping local contrast normalization for improved accuracy. First step of calculation is the computation of gradient values. The most common method is to simply apply the one-dimensional centered point discrete derivative mask in one or both the horizontal and vertical directions. Next, in the classification stage. Finally, the classification stage, here SVM classifier are used. Here the input video features and also the entire database features also passed into the classification algorithm. The SVM maps input vectors to a higher dimensional vector space where an optimal hyperplane is constructed. Among the many hyperplanes available, there is only one hyperplane that maximizes the distance between itself and the nearest data vectors of each category. This hyperplane, which maximizes the margin, is called the optimal separating hyperplane, and the margin is defined as the sum of distances of the hyperplane to the closest training vectors of each category. Finally, we retrieve the text from the particular frames of the video. Finally, the result will be obtained. Let me discuss about the running procedure for our process. Select the main.m file in the current folder, right-click the file and run for executing this process. This is the main window of the optimized searching of video based on speech and video text content. Select any one video by using the pop-up menu function. Here, I select the first video. By pressing the input video, we can load the video from the database. And here I display the video in the movie player format. And by pressing the frame conversion button, we convert our videos into number of frames. Here I display the first 50 frames in a figure format. And by pressing the pre-processing button, we pre-processed our video by each and every frames using the noise removal operator, that is Gaussian filter. After completing the pre-processed frames, we process our edge detection process. By pressing the text detection button, we can extract the edges of each and every frames. This process will be repeated for every frames. So here canny edge detection operation are used for edge detecting process. After completed the detected edge of process, we are going to extract the features. By using the feature extraction button, we can extract the HOG features. Here these features will be extracted for every frames. Here I display the extracted features in a table format, and this is the histogram representation of HOG features. By pressing the SVM classifier button, we perform the support vector machine operation. By using the classifier, we can retrieve the text from the video. This is the text for our video we have retrieved. And this is the recall and precision values for the SVM classifier performance, and this is the accuracy, sensitivity, and specificity for the SVM classifiers. And by pressing the analysis button, we can estimate the processing speed evaluation between mean processing time and also standard deviation. This bar graph represents the video loaded format, and this bar graph represents frame conversion, and this is for edge detection. This is the features extraction. This is extracting all features from our entire data set videos. Finally, we retrieve the lecture video from database as better than existing algorithm. This improved recognition rate and better result than existing approach. Thank you.